This just in on AKC News, possibly one of the best news cover stories you may ever hear. Here is Aaron Koso on the Unit Circle. Aaron. Hey, freak out. Aaron here. What is math? Alright. Well, the definition is the abstract science of number, quantity, and space. Mathematics may be studied in its own, pure mathematics, or as it is applied to other disciplines such as physics and engineering, applied mathematics. You see, it's just not that. Math is giving your best shot to every problem and really swinging that bat.
See?
Hey, are you okay, man? Yeah, man, I just get too excited over math. It's just, yeah, I'm sorry, it's just... Oh, well, I'm glad you're okay, but you broke $1,000 in equipment. What is wrong with you? Okay, we could point fingers all day, but it's whatever. Yes, I am pointing fingers at you. Okay, whatever. I have to teach this class, so just whatever. Leave, okay? Go. A whole $1,000 in money, you just blow me off. I can't believe this.
I struggled on how to showcase this circle. I thought about my whiteboard, but the background was too dark. Then I thought about my calendar, but that already had drawing on it.
So, I settled on string, but I still need a background, so let's use this corkboard. Seems a little bit dark. Ah, that's better. So I'm gonna make this board like this picture. Thank God to post-editing. So here's a time lapse of me doing that. Okay, so now that it's all set, we're gonna look at it.
Wait, isn't it upside down?
Really? Ugh. So that took a while. But let's divide it up even further. Whew. Now that's a lot of circle. Let's talk unit circle. So we're gonna split it into a basic part. 4 parts. 4 quadrants, if you will. 1, 2, 3, 4. Now, we go counterclockwise because I'm right and you're wrong. Just kidding. We start at 0 and we'll end here. It's a circle. We go full round, baby. But now we need to look at some points in the circle. So we're gonna look at these 3. But let's fill them in. Bam! Now we have these points. But we need to describe them. So if we're starting at 0, and let's say I'll give you this, is 90 degrees. Halfway should be 17. Yes, 45, correct. But now we need to describe these ways. So it kind of recalls for a little pattern. We go up for 30, up 15, up 15, up for 30. Up for 30, up 15, up 15, up for 30. So now that we know the pattern, we're done. We just figured all the circle out. Nice job. Just kidding, there's like 3 more ways to describe this thing. The next one we're going to talk about is radians. And this involves pi. I'm hungry. Okay, but we're starting at 0 again. And half of this is 1 pi. So another half would be 2 pi. So let's say, what's this one? Well, it's half of 1. So, yeah, pi over 2. That makes sense. But what about these trickier, smaller numbers? Knowing these smaller points calls for a lot of memorization. But some can be used as logic. We established this as 0, and this is pi over 2, right? So if we half that, if we half 1/2, it would be 1/4, which is logical because this is pi over 4. But now, what do we do with these guys? Now these are tricky, so I'm gonna give them to you. This is pi over 6, and this is pi over 3. Now, I'm gonna blow your brain for a second. If we take pi out of the equation, even though I said it was the basis of the unit circle, it makes things just a little bit easier. So, 1/6, 1/4, 1/3 could be kind of a pattern. 1/3 can also be described as 2/6. So now we have a similar denominator of 6 with these two. 1/6, 2/6. And 1/2 can also be described as 3/6. Okay, so there's a sort of pattern here, which is really, really nice. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. And this is 1, so it checks out. But what about these ones? You haven't used those yet, I hear you ask. But it's fine. It uses the same sort of pattern, just a little bit different. 1/4, 2/4, 3/4, 4/4. Okay, that makes sense. 4/4 is 1. We said this was 2/4, and that reduces down to 1/2, and pretty easy, right? Yeah, it is. Don't forget to replace that 1 with a pi. But, as we said, this is 3/4. You can't really replace that 3 with a pi, so it's going to be 3 pi over 4. So don't forget that. Whew. Alright, one more way to go. Now, this way is sort of a XY type of pattern, if you will. But watch what happens if I put a line right here. It makes a right angle. Now, as we described earlier, this was a 30-degree angle. So if we have a 30 degree, a 90 degree, oh my gosh, we have a special right triangle. So a sort of given in the unit circle is that a radius will always equal 1. So now that we have all the angles and we have a hypotenuse, we can actually solve this special right triangle with the functions of sine and cosine. So, if we take this XY type of pattern and make it into a cosine sine type of pattern, we can easily figure this entire unit circle out.
So with this lovely picture, we can now figure out this cosine sine xy type thing. So we're just going to go left to right and solve it out. So as you see, cosine of 30 equals x over 1. So we just multiply by 1 and then put it in the calculator, cosine of 30. I am in degrees mode, so make sure you're in that mode as well. And a little thing, 0.866 is also equal to square root of 3 over 2. And next we're going to solve out sine. Sine of 30 equals y over 1. Same deal, multiply that 1, put it in the calculator, that equals 0.5. We're going to put it into fractions as 1/2. So our final xy will be square root of 3 over 2, comma, 1/2. And there it is.
Man, I've just been seeing circles in everything. Just like this table. Oh my, the speaker. Oh, no.
I'm a circle.
Stop, that's creepy. No. Oh my god, it's fine, it's fine. Not the suns. No. No. Okay, you know what? I gotta go somewhere where there's no circles at all. Okay, Minecraft. All squares, right? Yeah, okay, here we go. Here we go. Okay. It's the end. This is the final boss. It's good. I have my enchanted diamond sword. We're good. Oops, I dropped it. Wait, what is that? Is that... the shadow's a circle. Wait. No. Ah! Well, there you have it. The perfect explanation of the unit circle. Oh, circle. I hope you learned something. Just a little bit. Please, Join me next week when I cover a story about literally anything but circles. See you then. John?
What was that? What was that? Now, onto the weather. Hey, thank you so much for taking the time out of your day to watch this. It was so fun to make. I'd like to give some special thanks to my sister Lillian for voicing that line about the circle being upside down, which I thought was kind of funny because, you know, a circle can't be upside down. But I'd also like to thank my dad for doing some camera work because that was really nice of him. And yeah, I really hope you enjoyed. It was, again, so much fun to make. So, sayonara. Or is it the end of the video? Hi, it's me again. Our weatherman had to be fired because we're trying to stay afloat because these crazy times. But here's the weather. Well, my forecast says, here, let me just show you. It's raining! Okay, that was really it, I promise. There's nothing else. Thank you so much, Marshall Morrison, for teaching me this class. I had such a blast this year. So sad that it got cut short, but thank you so much for teaching me. It was so much fun. So I really hope you liked it. Goodbye again. For real this time, I promise.